Hello and welcome to Taming the Beast, how a SQL Server DBA can keep Kerberos under control. My name is David Postlethwaite. I'm a SQL Server database administrator for a large insurance company on the south coast of England. I've been working as a DBA for the last 6 years and I currently manage SQL and Oracle instances including database, analysis services, integration and reporting services. Previously to that, I was a developer using .NET, SQL, Access, FoxPro and Oracle, and before that I was a Windows and a NetWare administrator. I contribute to the blog on gethandellis.com, and if you wish to get hold of me, my email address is on the screen. Now, if I was to do a survey of some SQL Server DBAs, I'm sure many of them will have had to have tried to configure Kerberos for SQL, and I'm sure if I pushed them, many of them would say that they'd had a lot of problems configuring Kerberos. It's something that causes lots of problems for many SQL DBAs, as well as many Windows Servers administrators, but configuring Kerberos isn't that difficult. What should be a straightforward and simple process can lead to all sorts of issues, and trying to resolve them can sometimes be hard work. In this talk, we're going to look at Kerberos, how it applies to SQL Server, and what we need to do to ensure it works. So we're going to look at what is it? What is the purpose of Kerberos in relation to SQL Server? When do we need to use it? Do we need to worry about it at all? How do we configure it? What tools can we use to make Kerberos work? Who can configure it? Is it the job of the SQL DBA? Or is it someone else's job? Why does it cause so many issues? Because on the face of it, setting up Kerberos for SQL Server is actually straightforward. It's very easy to get wrong and sometimes very difficult to see what is wrong. And finally, how do we fix it? When it doesn't work, what can we do to try and get it working? Before I look at Kerberos, I want to give a scenario where Kerberos authentication is required for SQL Server. This is a diagram of my Windows setup. I have an Active Directory domain called CW1. I've got a domain controller called S007, and I have two SQL servers. Server S008, which is where we're going to spend most of our time, and a second server S006. My servers are running using a domain account called SQL Service 2, and I have my laptop over here, Clooney 10. I'm logged in as a domain administrator, and I've got sysadmin permissions on all the SQL instances. Right, so let's flip over to our server S008. So here I am on my remote server called S008. I'm connected in Management Studio, and you can see that we have a database called AdventureWorks. I've created a little table called T1 for this little experiment, nothing particularly clever. Now, one of the things I can do is import some data from a data file. Here I'm going to do a bulk insert from a file on the local disk, which of course is nothing particularly difficult, and that can read in those 1,000 rows in that CSV file, no trouble at all, as you would expect. Now here, I'm going to bulk insert from a file which is on a different server. In this case, it's on the remote server called S006. And if I run that particular statement, no difference, exactly the same data file, you'll see that it reads in 1,000 rows without any trouble at all from that remote server. You wouldn't expect anything different. Now, if we want to read data from a remote server, we can use an ad hoc query using the open row set command, and here I am connecting to the SQL Server S006 and pulling some data out of the AdventureWorks table on that server. And unsurprisingly, we can see it returning data down here, 10 rows in that case. Now, if we wanted to, we can create a linked server as well. So let me just copy and paste that in here, and let's go and create a link server to that SQL Server. So we're going to create a SQL Server link. It's going to be to my server on S06, and the important point is we are going to say in the security context be made using the login's current security context, which means that this SQL Server will pass my credentials through to the remote server and use those to connect and pull data back. So we can use the open query statement to select again 10 rows from the AdventureWorks table on that remote server. And similarly, we can use a similar type command just to pull back the database is on that remote server, and that works quite happily as you would expect it to. Nothing difficult about what we've done there. Now let's move over to my desktop where I have Management Studio running, and I have a similar set of commands set up here. Now let's try that bulk insert command again. So I'm going to bulk insert from S008 to 006 and pull that data file in and read it. And what happens if I select it correctly and run it? We get an error message, access denied, which is a bit strange because I'm a domain administrator. I know I have access to that data file. So why is it stopping me from being able to read it? Similarly, if I try running that ad hoc query to pull data back from S006, we will also get an error message, and this time login failed for NT authority anonymous login, which is a bit strange because, as you can see here, I'm actually connected to S006. So why can't I pull data back via S008? If I try the link server, I get exactly the same error message, and if I try the link server the other way, I also fail, which doesn't make sense because I know I have access. Why can't I gain access to S006 via S008? And this is the problem that we are suffering. The only way to fix this is by enabling Kerberos. So let me flip back to my slides. We have hit what is known as the double hop problem, which isn't some fancy Morris dance, but actually a problem where we are trying to go from my desktop through the first SQL Server to the second SQL Server. We cannot do it. It will crash and give errors. So why does our query fail? Well, Windows uses NTLM for its authentication, and this is a challenge response protocol to authenticate a user and avoid sending the password over the network. Instead, the system requesting authentication must perform a calculation that proves it has access to your login credentials. So to keep it simple, I've missed out a few steps. So a user logs in to a client computer and provides his domain name, his username and password. The client PC computes a cryptographic hash of the password and then discards the actual password. It uses this to log into the Windows domain. The client now wants to connect to the SQL Server. It sends the username to the server in plain text. The server generates a 16-byte random number called a challenge and sends it back to the client. The client encrypts this challenge with a hash of the user's password and returns the result to the server, and this is called the response. The SQL Server sends to the domain controller all this information, the username, the challenge, and the response. The domain controller can now look up the user in Active Directory and then compute its own version of the response from the password hash in Active Directory and the challenge it received from the SQL Server. The domain controller can now compare the response it computed in step 6 to the response computed by the client in step 4, and if they are identical, authentication is successful. So what happens when SQL Server tries to authenticate to a second SQL Server or Windows Server? As we've just seen, when the client wants to access to use a resource, it must go through the challenge. So the SQL Server wants to connect to the file server using the client's credential. The user is authenticated to the first SQL Server. The first SQL Server sends the client's username to the second server. The second server generates this 16-byte random number challenge and sends it back to the SQL Server. The first SQL Server now needs to encrypt that challenge with a hash of the user's password to return to the file server. But it can't, because it doesn't know what that hash is. This is only held on the client PC, and the client PC will not pass it to anything else. So the connection fails, and this is why NTLM fails. The process cannot authenticate to the next hop without the user's original password, something it can't get. The result, the process can only authenticate to the next tier as itself, or null, or anonymous, and so it fails. Kerberos and its ability to delegate is the solution to the problem. So what is Kerberos? Kerberos is a network authentication protocol developed at the Massachusetts Institute of Technology in the USA in the 1980s. The name Kerberos comes from the three-headed dog figure from Greek mythology known as Kerberos, spelt with a C, because there are three parts to the Kerberos protocol. Or possibly it's come from Harry Potter. For those of you who are Potter fans will remember that Hagrid owned a Kerberos called Fluffy that guarded the Philosopher's Stone. Now, instead of using a challenge each time a client needs to access a server, Kerberos uses the concept of cryptographic tickets, which will become more apparent as we move on. Kerberos is faster and more secure than NTLM, and with a threat of hacking and data theft, we should be looking to use Kerberos authentication throughout our Windows domain. With the latest Windows 2012 R2 domain, it's now possible to turn off NTLM authentication, and I'd expect one day for NTLM will be dropped from Windows altogether. One major advantage of Kerberos authentication is that you can join Windows domains to other networks such as Unix, allowing you to have one password domain covering all of your systems. Now, interestingly, prior to the changes in US federal law in 2000, Kerberos was classified by the US government as a munition, i.e. a military weapon, and could not be exported out of the USA. It was only the changing of that law that allowed Microsoft and others to start putting it in to their software. So how does Kerberos works? Well, there are three key components to Kerberos. We have a key distribution center, which has two parts, an authentication server and a ticket granting service. In Windows, this is the domain controller. We have a client and we have a server that the client wants to access. So first of all, the user enters his login name, password and domain. The client passes that information to the authentication server for verification. It then grants the client a TGT, a ticket granting ticket. Think of the TGT as a general admission ticket to the domain. It allows the user permission to get onto the domain, but not necessarily access to a specific service. When the client wants to connect to the SQL Server, the client uses its TGT to request a service ticket from the KDC. The KDC looks up the SQL Server in Active Directory. If the SQL Server is configured for Kerberos authentication, the ticket granting service provides a service ticket for that SQL Server to the client. Think of the service ticket as an admission ticket for a specific service within that domain. The client can now offer the SQL Server its TGT and its S service ticket. The SQL Server doesn't need to contact the domain controller for verification. The fact that the client has provided a TGT and a service ticket for the SQL service means that it has already proven its identity to the domain controller, and that's all the SQL Server needs to know. It does not need to know the user's password, and the SQL Server can now return data to the client, assuming SQL permissions are correct. When the SQL Server sees it needs to contact a second SQL Server, it uses the client's TGT to request a service ticket for that server from the KDC. With this service ticket, the SQL Server can now connect to the second SQL Server using the client's credentials. The SQL Server can now return data to the client. As you can see, Kerberos doesn't depend on the original user's password for authentication. The only time the original password is used is when the user logs in and authenticates to his authentication server. After that point, authentication to other servers is based on the user possessing a service ticket for that server. For the SQL Server to authenticate to the second server, all it needs is the client's TGT and ST. So why doesn't SQL always use Kerberos? Kerberos is now the default protocol used by Active Directory. In a Windows domain, you will have logged into your PC using Kerberos authentication. However, many services and applications don't yet support Kerberos authentication or require extra configuration to be able to use it. Every time you log in or connect to a server, it will always first attempt to use Kerberos, and if it can't, it will revert back to NTLM authentication. In many cases, SQL Server requires manual configuration to use Kerberos, so in these cases you will use NTLM authentication when connecting to a SQL instance. So how do we configure Kerberos in Windows? As already mentioned, Kerberos is the default protocol used by Active Directory, and your SQL Server may already be using Kerberos authentication without you having to do anything. If not, then you'll have to configure it manually. To configure a service such as SQL to use Kerberos, you need to be a domain Windows administrator, or as a minimum have the right service principal name Active Directory permission. So the good news is that Kerberos configuration is probably not done by you, the DBA, but by a Windows administrator. In my experience, lots of Windows admins don't understand Kerberos either, so although you won't be doing the work, it's worth understanding what's required, and even better, be able to tell the Windows admin what they need to do. To enable Kerberos authentication on a SQL instance, we must register what is called a server principal name, or an SPN, for our service. SPN is a unique name by which a client can identify a service on a particular host, and these are stored in the Active Directory. Now, like most things that people struggle to understand, Microsoft has only produced a simple command line tool to configure it, and this tool is called setspn.exe. It should already be installed on all your Windows servers. If it's not installed on your desktop, you can download it as part of the remote administration tools, or it's also part of the Windows 8 installation. So to create an SPN, we need four things. We need the service class. This is a general class name by which the service is known, and for SQL Server this is always MS SQL Service. You need the host name, which is the fully qualified domain name in DNS of the computer that is running the SQL Server. You need a port number of the service that it's listening on, and the account name that the service is running under. So in an example, here we go. So set SPN -S, which is used to create the SPNs, MS SQL Service, the name of your SQL Server, :1433, and then the service account which it is running under. If you have any aliases, you need to make sure that you create aliases for every single alias, and you must restart your SQL Server afterwards so that it can register and see the SPN for it. And that's it. Once you've done that, you are now configured for Kerberos. One further step that we need to do to allow the delegation, i.e. the passing of the permissions from one server to another, is to enable delegation for the double hop. And this is done in a program called Active Directory Users and Computers. If you've not ever used Active Directory Users and Computers, I would recommend you get it installed on your desktop. It is probably one of the most handy tools that I have ever had to use. This is the tool that is used for configuring all the users and groups and computers in Active Directory. It's very handy for being able to look up users. When they say they can't connect, you can check their permissions, what groups they are in, and see why they're not able to connect to their instance. So we would need to turn on delegation. We would look up our service account, and the delegation tab will appear if that account has an SPN configured, and then we can turn on the option trust this user for delegation to any service, which gives it blanket permissions to connect to any service, SQL or otherwise, on your domain. Or if you wish, you can limit it to any particular servers on your server if that is what you wish. And then everything will start working. Finally, how can you tell whether your SQL instance is actually running Kerberos? Well, as always, Microsoft have come up with a DMV, and this is it, DM exec connections, and we can use that query later on to prove whether we are running Kerberos or otherwise. So let's see if we can get this to work. Let us flip back to our remote server, and let's see what we can do. So we need to create some SPNs first of all. So I have a batch file that is set up to do this. If I double click on that, and then we can zoom in, you can see here it is. So I'm going to run set SPN -s. We have MS SQL Service, which is our name, service name, then followed by the fully qualified domain name of my instance, and then the service account which the server is running under. So if I run that, it should now go away and update the object. I'm now going to do it again, and this time you will see that I'm doing exactly the same thing. I've added :1433 to it to make sure that we have an SPN that is configured with the port number and without. So if we run that, that is now updated. Now I'm just going to run a set SPN -l against that service count, which allows me to check whether the SPNs now exist, and there it lists them out for us. MS SQL Service, da da da. So that is now done, and that makes us happy. The final part, we need to go into Active Directory Users and Computers. I need to find that account. So if I look up SQL Service 2, there he is. Here's the information. There's the delegation tab. And I'm going to, for simplicity and time, just say trust this user for delegation to any service. Click OK, and that is all the steps done. The final part is to restart our SQL service. If I can find it, the query, there we are. So let's restart SQL, but I need to do it as an administrator, don't I? Run as administrator. Yes. So that will now stop my SQL Server, and we will start it again. And there we have it. conveniently started. So now let's flip back to my desktop, reconnect this query to my server as we restarted it, and let's see whether this query now runs. And there we have it. We are now doing our Kerberos double hop. We have successfully connected to server 6 through server 8, just to prove it. There we are, it says server 8 from my desktop. And if we come down here and run our connection check, we will see there is my connection using Kerberos authentication. All done and dusted. Easy, simple. So the question is, why does everyone have so many problems with Kerberos? Let's flip back to my PowerPoint. Why does everyone have so many problems when it should be as simple as I've just shown you? Well, the most common mistake used to be creating duplicate SPNs. That SPN command I was using to create our SPNs, in the early versions of that program, you could run that command over and over and over again, and it would just create more and more SPNs of exactly the same piece of information. It did not stop you from creating a duplicate. Once you have a duplicate, how does the service know which one it needs to create its service ticket for to connect? So it would nearly always fail. Now the good news is that the later versions of SPN now have the -S option for creating SPNs, and that will check for a duplicate and stop you from creating duplicates, which is an excellent improvement. And the latest version, which comes with Windows 2012, even the -A option, which was the original add option, will check for duplicate SPNs as well. So it is now very, very difficult to create a duplicate SPN. You can look for duplicates using the -X option. You can delete SPNs using the -D. And as you see, we've used the -L to list out for a particular account, so we can see if there are more than one of the same thing listed. So do watch out for duplicate SPNs. Start having a hunt. You'll probably find that your network does have quite a number. Incorrect SPNs. There's nothing to stop you typing it in with a spelling mistake. The disadvantage of a command line tool, you can put the service name wrong, you can put anything wrong, it will not object. Be careful that you put the server name in correctly, that it is the fully qualified domain name and not just the server name, as that can fail. Make sure you're registering all your aliases. If you're using aliases to connect to a particular server, you need to make sure that they have been added as well, otherwise you will not get a connection. Make sure you have listed the correct service account. If you are using domain accounts for your SQL Server service, make sure it is correct. Otherwise, it will not have the right information that it needs to be able to make that connection. If you change the service account on your SQL Server, you must also recreate your SPNs. You must drop the ones you had and create new ones, otherwise it will not work. Don't forget to enable delegation in Active Directory users and computers if you want to have that connection and that double hop to work. It is very important not to forget that bit. Forgetting to restart SQL. SQL will not notice that SPN until it has been restarted. So you must remember to do that. If you have a large Active Directory with many domain controllers, you may have to wait for your Active Directory to replicate that information around to all the different domain controllers before SQL or you or your account, your desktop, will be able to see the new SPNs and use them. Something that I've come across, stale Kerberos tickets. Sometimes your tickets are cached on your PC, and when you try and connect, it tries to use that cached information, which is incorrect. You should find on your PCs a command called klist.exe, which allows you to list and purge your Kerberos tickets, forcing your client to go and get some new tickets from the domain controller. and that has helped me on occasion. Sensitive clients, there is an option in Active Directory in your account that says account is sensitive and cannot be delegated. If that has been ticked, then you will not be able to move from one server to the other. It will just not work. So watch out for that particular option. I've not come across anyone, but that could be something that catches you out. Time synchronization, Active Directory and especially Kerberos is very time sensitive, so it's very important to make sure that all your domain controllers and PCs and servers all are showing the same time. Otherwise you may find that Kerberos will refuse the connection because the ticket is too old or out of date. Watch out for dynamic ports on your servers or even dynamic IP addresses. I'd hope that all your servers have fixed IP addresses, because otherwise every time the IP address changes you're going to have to drop your SPNs and recreate them. So I don't think that's too much of an issue with most people, but could happen to someone. Make sure that the server at the end of the hop is configured for Kerberos, otherwise it will not understand the ticket that it's trying to receive. Host file, this did catch me out. If you do use a host file on your desktop or your server, do make sure it's got the fully qualified domain name in it, otherwise it may not be able to resolve the name correctly. Better off don't use host files at all. And sometimes you just have to be patient and wait for everything to replicate around, sort itself out and work. There are most of the main problems. Now, you may remember I said we had set SPN for creating our SPNs, and what a pain it was. Well, Microsoft have finally, in the last couple of years, come up with a GUI specifically for SQL Server DBAs to help us create our SPNs, called Kerberos Configuration Manager for SQL Server. If you're doing anything Kerberos as a DBA, I suggest you download this, get it installed, and it will make your life much easier. Not only will it interrogate your SQL servers and tell you what the SPNs should be, it will tell you whether they're correct, and it will even write the scripts, the batch files that you can give to your Windows administrators with the correct command in for creating SPNs. So let's just flip back to here and let's load up Kerberos Configuration Manager on this server and we'll have a quick look at it. Now, so let's just connect. Because I'm on a server, I don't need to enter any details. It will just take my name and the current server name. Now, the latest version of Kerberos Configuration Manager is version 3, which will work with SQL 2014 instances. The previous version that I've been using was version 2, which didn't recognize 2014. But do be careful if you do use version 3. If your instance doesn't have a 2014 instance running on it, then it will not work. It won't even find the 2012 instances. So do watch out for that. So if we look at this server, SPN, there's quite a number of instances running on here, different versions, and we can see over here that it's showing the ones that I've just done are good. This particular one, which is an analysis service, it's missing those SPNs. They're not registered where it thinks they should be, and it gives us the option here to generate a batch file which we can have a look at and send the appropriate lines off to our Windows administrator to create it. Or if we actually have permissions, Active Directory permissions, then we can automatically fix it just by pressing that button, and it will go off and add the SPN automatically into Active Directory for us. So this is the tool. It can also show us whether our delegation is working correctly, whether we've configured our delegation. And as you can see, I've got a full delegation, and it's warning us that that may not be the best security option available. So this tool is definitely worth getting hold of. This is version 3, and you can see, as well as database, it can offer SPNs for reporting services and analysis services. So it's a very handy tool if you're doing anything in SQL Server around authentication and Kerberos. This is the tool. It makes life so much easier for you. You can guarantee, well, you can guarantee that you'll get the right batch, the right command to create your SPNs. So definitely go and download this if you are doing anything. Now let's just flip back to my PowerPoint again. Where is it? Here we go. So just some final thoughts. You may be wondering why you have to go through all the pain of creating SPNs manually. Why can't SQL Server just create them automatically? Well, SQL Server can, and it does. When SQL Server starts up, it will automatically try and register an SPN. If your service account was a domain account, or you're using one of the built-in accounts, such as local system, it will automatically create the SPN when it starts up. If it can't, this is the sort of error message you'll see. SQL Server is attempting to register an SPN for SQL Server service. Kerberos authentication will not be possible until an SPN is registered. This is an informational message. No user action is required. So if it can't create it automatically, then this is why you have to do it manually. So obviously, if you gave your domain account, that service account, domain admin permissions, which I hope you never would, or maybe just the right service principal name permission, then you would be able to get it to do it automatically for you, which is a bit beyond the scope of this talk, managing Active Directory. Now, those of you who are using SQL Server 2012, 2014 and above will have probably know about local and virtual accounts such as NT Service / MS SQL Server. These can register automatically. Because they're a local account, they will automatically register an SPN when SQL Server starts up and will drop that SPN when SQL Server shuts down. You do not have to do anything to do that. Must be running on Windows Server 2008 R2 and above, but that's probably where you are anyway. So you'll probably find that a lot of your SQL servers, if they are running using one of these local or virtual accounts, is already running under Kerberos authentication and you didn't have to do anything. Generally, it's only if you are using a domain account or a local account of some kind, Windows account, that you would need to manually configure it, which was how we used to do SQL Server in the old days. But now that we have all these local and virtual accounts, life is easy. You probably don't have to do anything. It's already done. All you would need to do is set up the delegation once it's running. So that is about it. If you are registering one for a local account, you need to register the server name and not the account name. So you'd end up with something looking more like that. But I would imagine that's becoming a bit rarer. There are lots of articles on the internet. This is quite a useful one that I've used on setting up Kerberos and answering some questions. We haven't talked about SSRS, but this is probably another case where you may be needing to make sure Kerberos is configured correctly on your SSRS server, because you may be going from a web browser from your client to the SSRS server and then onto a SQL server. So again, you've got that 3-hop problem if the security is set up to pass through, and you may need to do some configuration there. An article again that I found, which is quite useful for talking about SSRS configuration. So hopefully that has given you a good idea of configuring Kerberos for SQL Server, and I hope that you will find this talk useful. Thank you very much for listening, and good luck with your Kerberos configuration.